Good morning, good afternoon, good evening. Welcome to TMMS educational videos. In this channel, you will learn physics, chemistry, and maths concepts of senior school. I have been teaching since 1981, and you can learn all the tricks and tips I have collected in all these years. Also, 80% of my students secure 90% plus marks and have a history of toppers of number of schools in the ICSE board exam. If you are new to my channel, click on that subscribe button and comment on what you think of it. I'd love to hear from you. Gay-Lussac's law. When we talk about gas laws, we think about Boyle's law, which gives us the statement P1V1 equal to P2V2. This is the equation derived from Boyle's law. Then we come to Charles' law. This one gives us the equation V1 upon T1 equal to V2 upon T2. And when we combine the two, we will get P1 V1 upon T1 equal to P2 V2 upon T2. Now, these laws, it gives us the behavior of the volume of the gas when the temperature or the pressure, they are changed or both of them are changed together. But when we want the gases to combine with each other, when they react with each other, what happens to the volume of those? And that is given by Gay-Lussac's law. What does Gay-Lussac's law say? When gases combine, they do so in volumes which bear simple whole number ratio to one another and to the volumes of the products if gaseous. So you see that we talk about the volumes, and the volumes bear simple whole number ratio, which means there will be no fractional ratio. To one another means the reactants, and to the volumes of products if gaseous. And provided, what is the condition? That the temperature and the pressure of what? The reacting gases and their products, if this is the same. So now let us understand this with the key words highlighted. Let us understand this really well. When gases combine, they do so in volumes which bear simple whole number ratio to one another and to the volumes of products if gaseous, provided the temperature and the pressure of the reacting gases and their products remains constant. So, did we understand this? Last time, when gases combine, they do so in volumes which bear simple whole number ratio to one another and to the volumes of products if gaseous, provided the temperature and pressure of the reacting gases and their products remains constant. Now, you have to learn this law by heart, because the question will come, state Gay-Lussac's law. So you need to understand and write it down. The second part is where we will be asked to apply Gay-Lussac's law, which means you need to solve the numericals. Now, numericals, many of you don't like, correct? So we need the tips to understand how to apply Gay-Lussac's law. So let us see just that. Let us understand the law first. So let us say we have nitrogen and it is combined with hydrogen and it is going to give us ammonia gas, and the balanced reaction looks like this. So we have one molecule of nitrogen combining with 3 molecules of hydrogen and it is giving us 2 volumes of ammonia, which means if this is 1 volume of nitrogen, it will combine with 3 volumes of hydrogen and that will give us 2 volumes of ammonia. And this is because of our Gay-Lussac's law. What does Gay-Lussac's law say? You have to know this by heart. So when the gases combine, see N2 and H2 they are combining, they do so in volumes which bear simple whole number ratio to one another. So with one another, what is the ratio? 1:3. And to the volumes of the products if gaseous. Is this a gas? Yes. So this is a gas, this is a gas, and the product also is a gas. So here it is 2 volumes, and that is the ratio of the product, and provided the temperature and pressure of all these means what? The reacting gases and their products remains the same. Now let us see how we can apply this. Supposing I take 20 ml of nitrogen. So 20 ml of nitrogen becomes 1 volume. So it will combine with 3 into 20 ml, which means it will combine with 60 ml of hydrogen. And my product will be 20 multiplied by 2, that is 20 into 2, which is 40 ml. Did we understand how we connected the law with the numbers here when the volumes were given? 20 ml of nitrogen, if it's provided, it will require, according to the equation, 60 ml of hydrogen in order to get 40 ml of ammonia. Now, let us take proper questions from ICSE examinations. This is 2012 question. Question number 5A. 67.2 liters of hydrogen combines with 44.8 liters of nitrogen to form ammonia under specific conditions as N2, which is a gas, plus 3H2, which is again a gas, gives us 2NH3, which is again a gas. Calculate the volume of ammonia produced. What is the other substance, if any, that remains in the resultant mixture? Now, tip number 1 is to write the equation and write the data that is given in it. So let us see how we proceed with that. So we have written the equation and we have written the data that is given and the data that is to be found out. This is our tip number 1. Tip number 2 is write according to the equation the ratio of the volumes. This is 1 molecule of nitrogen, so this becomes 1 volume, is to, this is 3 molecules, so that represents 3 volumes of H2, and that gives us 2 volumes of ammonia, as you can see, and this is by Gay-Lussac's law. Okay, now we are going to look at 1 volume being 44.8. Now, if this is 1 volume, then 3 volumes will be 3 multiplied by 44.8. Now, 3 multiplied by 44.8 definitely is going to be more than 67.2 liters. And so, you are going to consider 67.2 liters as 3 volume. So, we are going to say 3 volumes correspond to 67.2 liters. So 1 volume is going to be how much? And so this, if I call as X, it will be equal to 67.2 upon 3. How much is that? 3 to 6, then again 3 to 6, and remain 1 and 22.4. This is our tip number 2. Now we look at the equation and we will say here this is 1 multiplied by 22.4 liters because 1 volume is 22.4 liters is to this 3 volumes becomes 3 into 22.4 liters, and that will give us 2 volumes will be 2 multiplied by 22.4 liters. Did we get this part? Let us understand once again. If I consider 1 volume as 44.8 liters, then 3 volumes will be 3 multiplied by 44.8 liters. That number will be definitely more than 100. So it will be more than this number. So we cannot consider 1 volume as 44.8 liters. So what we have to do is we have to look at the volume of H2, which is 3 volumes. So we say 3 volumes is 67.2 liters. So we say 3 volumes are going to be equal to 67.2 liters. So one volume is going to be 67.2 divided by 3, and that is 22.4 liters. Once we get this, you are going to look at the equation and we will say one volume is 22.4 liters. So it will be 1 into 22.4 liters. 3 volumes become 3 into 22.4 liters and 2 volumes become 2 into 22.4 liters. Did we get this much? Now, what is our first question? Volume of ammonia. So now volume of ammonia is going to be equal to 2 into 22.4 liters. Look at our equation. Can you spot this? Did we spot this? So 2 into 22 becomes 44.8 liters. And this will be at the same conditions of temperature and pressure. And this becomes our answer 1. Now, in our second part, they are asking resultant mixture if any other substance is there. Now look at our nitrogen. Nitrogen was 44.8 liters. How much of that nitrogen was used up? Wasn't it 22.4 liters used up? So we will have a little bit of nitrogen remaining, and that will go in the resultant mixture. What about hydrogen? Hydrogen is 67.2 liters. And how much of hydrogen did we use up? 3 into 22.4 liters we used up, which means all of it, 67.2 liters was used up, correct? And so we are going to have no hydrogen left, but now here we'll have 2 volume, which means 2 into 22.4 liters, that is 44.8 liters of ammonia. But we will have the unreacted nitrogen also. So we will write just that. We will say volume of nitrogen used is going to be equal to 22.4 liters. Therefore, volume of unused nitrogen will be 44.8 liters minus 22.4 liters, which is equal to 22.4 liters. So this is unused, or it is the unreacted. And so the other substance in the resulting mixture will be 22.4 liters of nitrogen. So apart from ammonia, how much is the ammonia? The ammonia was 44.8 liters. And now apart from that, we will have the unreacted nitrogen also, and that is our answer. Let us look at 2013 question. See, you can see T13. It is the question of 2013 ICSE examination paper. Look at our question 1G, which means this question has come in section 1, which is compulsory section. What volume of oxygen is required to burn completely 90 dm cube of butane under similar conditions of temperature and pressure? And this is the reaction given. This is a gas, this is also a gas, this is a gas, and this also is a gas. And when it is similar conditions, we'll consider this as a steam. If we consider this as a steam, then yes, this is going to be in gaseous state. Now, tip number 1, remember what I told you. Write the reaction and write the data that is given and data to be found out. So we've done just that. Writing 90 dm cube for butane, and we are expected to find the volume of oxygen. Now, all of these are gases, so we can apply Gay-Lussac's law. How do we apply? If this is 2 molecules, it will represent 2 volume. There are 13 molecules, so that will be 13 volume. And that will give us here 8 volumes, and here 10 volumes. And this will be according to which law? Gay-Lussac's law of combining volumes. Do you know this law by heart? You must know the law by heart. Alright? Now, let us look at this. If two volumes are 90 dm cube, so one volume becomes how much? How much is one volume? So we will write two volumes correspond to 90 centimeter cube, and so one volume will correspond to 90 upon 2, sorry, this is dm cube, upon 90 upon 2, which is 45 dm cube. Okay, so if there are two volumes, we will write it will be 2 multiplied by 45 dm cube. Why would we do that? Because one volume came out to be how much? How much is it? 45 dm cube, right? Okay, now let us look at this. These are 13 volumes. What should we write over there? Come on, tell me fast. Won't it be this? And that is going to give us 8 volumes here, means 8 into 45 dm cube, and that is for our CO2, and for H2O it will be 10 into 45 dm cube. Our question is to find the volume of oxygen. So what we are going to say, we'll say volume of oxygen required will be equal to 13 into 45, those many dm cube, correct? So that gives us 13 5s 65, carry 6, 13 4s 52, 52 and 6 will be 58. So 585 dm cube. And that is our answer. Wasn't that easy? Are we understanding all the tips? Is the concept clear? Are we understanding this better? Now we come to 2017 ICSE question paper. And question number 5A, which means now it has come in section 2, which is a choice question. Let us understand what the question is. Propane burns in air according to the following equation. C3H8 plus 5O2 gives 3CO2 plus 4H2O. What volume of propane is consumed on using 1000 centimeter cube of air, considering only 20% of the air contains oxygen? What was our tip number 1? That's right. First, write the reaction. Tip number 2, write the data that is given and what is asked. Okay. Tip number 3, apply Gay-Lussac's law to write the ratio. Shall we do just that? So we have written the equation and we are expected to find the volume of C3H8, which is propane. Okay. And volume of air has been given. Now, before even we touch this, let us look at what is our ratio of the combining volumes and the volumes of the products. This is one molecule, so this is one volume. These are 5 molecules, so this is 5 volume of oxygen. And this is 3 CO2, so that is 3 volume. Here it is 4 volumes. And this will be steam because we are burning it. And here we will say according to Gay-Lussac's law. Okay, we are clear about this, tip number 1, tip number 2. And now let us look at what else has been given. We are not given any oxygen, we are not given any carbon dioxide, we are not given even the steam, but we are given, what are we given? We are given air. And how much is that air? Air is 1000 centimeter cube. And so we have to say, therefore, volume of oxygen is going to be 20% of 1000 centimeter cube, which is the volume of the air. And that will come out to be 20 upon 100 multiplied by 1000, and that will give us 200 centimeter cube as the volume of oxygen. Now this volume of oxygen that we have, we will write here as like so on top of the oxygen in the reaction. So what does this give us? It gives us 5 volumes is equal to 200 centimeter cube. And now can you find how much is 1 volume? Can you? Yes, right? So you're going to do just that. I'm going to give you time starting from now, and you are going to complete this on your own. So we say 5 volumes of oxygen is 200 centimeter cube, right? So 1 volume of oxygen becomes 200 upon 5. How much is that? 40 centimeter cube. That's right. So now 1 volume is 40 centimeter cube will be now substituted in this line. By Gay-Lussac's law, 1 volume becomes 1 into 40 centimeter cube. This becomes 5 into 40 centimeter cube. This becomes 3 into 40 centimeter cube. This becomes 4 into 40 centimeter cube. But they are asking us only the volume of propane. So volume of propane, that is C3H8. How much is that? So we write just that, and that's our answer. Did you get that right? If you got that right, give yourself a lovely star. Okay. Now I'm going to take a little bit of variation over here. What would you have written if they had to tell you volume of the resulting mixture? In that case, you would have said 3 volumes of CO2, that is 3 into 40, which is 120 centimeter cube of CO2. And how much of steam would it have? 4 into 40 will be 160 centimeter cube of steam. Okay, so far good. Now, I want you to tell me the resultant mixture at room temperature. If it's at room temperature, what do you think this will be? This will become water. And if this is water, then in that case, we will have to write over here not applicable. Why not applicable? Because if this is in liquid state, then I cannot apply Gay-Lussac's law. Can you? You cannot. And that is why we will have only 3 into 40, that is 120 centimeter cube of carbon dioxide in our resultant mixture. Because to a substance in liquid state, we cannot apply Gay-Lussac's law. Gay-Lussac's law is only for the gaseous products. Got that? Let's move to one more question. So, a mixture of 20 centimeter cube of carbon monoxide, 100 centimeter cube of H2, that is hydrogen, and 1500 centimeter cube of air containing 20% oxygen, this mixture is ignited. Find the composition of resultant mixture at room temperature. Now out here, understand this room temperature is going to be tricky. But all in all, let us find how to use the information that you learned, the different tips that you learned, and let us look at the solution. First, we'll have to write the equations. Now there are 2 gases. Can you see CO and H2? So we will have to show different reactions like so. So we are going to write CO plus O2, and that is going to give us CO2. And here we will have H2 plus O2, and that will give us H2O. Let us balance this. We will have to have 2 CO and we'll get 2 CO2. Here we will have 2 H2 plus O2 gives us 2 H2O, and the 2 reactions are balanced. Now out here, can you see this 1500 centimeter cube of air? So air containing oxygen, so they have indirectly given us the volume of oxygen. So even before we apply our tip number 2, we will have to find out how much is the oxygen. So we will write volume of air is 1500 centimeter cube. Therefore, volume of oxygen is going to be 20 upon 100 multiplied by 1500. How much is that? 15 to 30, so that becomes 300 centimeter cube. Did we get that? Now, let us apply Gay-Lussac's law, and tip number 2 will be writing the volume. So this will be 2 volume is to here 1 volume, and that will give us 2 volume, and here again 2 volumes is to here 1 volume, and that is giving us 2 volume. Why do we say that? This is by Gay-Lussac's law. Correct? Now, what is our tip number 3? You have written this, but we have to write the data that is given also. So 20 centimeter cube should be written here, and here 100 centimeter cube should be written here. Now let us look at what is given. 2 volumes are 20 centimeter cube. You can do this mentally. So 1 volume becomes 10 centimeter cube. So we have 2 multiplied by 10 centimeter cube is to here we will write 1 into 10 centimeter cube gives 2 into 10 centimeter cube by Gay-Lussac's law. Now here 100 centimeter cubes are 2 volume. So 1 volume becomes 50. You can do that mentally, right? So this will be 2 into 50 centimeter cube is to 1 into 50 centimeter cube gives us 2 into 50 centimeter cube. Got that? All right. Now, how much of oxygen is used up here? 10 centimeter cube. How much of oxygen is used up over here? 50 centimeter cube. What is the product formed here? 2 into 10, that is 20 centimeter cube of carbon dioxide. What is the product over here? 2 into 50 centimeter cube. But can you see this is water? And can you see that this is room temperature? So what we will say over here? This will be written as not applicable. Did we understand this part? Because at room temperature, this water is going to be a liquid. Did we get that? So, let us see what is the composition of our resulting mixture. So, number 1, we will say volume of O2 used is going to be 10 centimeter cube from this equation and plus 50 centimeter cube from this equation. Total will be 60 centimeter cube. This is oxygen that is used. Therefore, unused oxygen is going to be equal to, from the total 300, we will remove 60. That will give us 240 centimeter cube of oxygen. Second part. Now, don't you think if we had 1500 centimeter cube of air, the balance air also will be there in the resultant mixture? So we write just that. Volume of air without oxygen. And that becomes actually volume of nitrogen. Understand that air has 20% nearly oxygen and remaining 80% is nitrogen. So we will have to write the remaining air as volume of nitrogen, and that will be 1500 minus how much was oxygen? 300. And so 1200 centimeter cube is the volume of nitrogen. Now what else do we have? We have volume of, in this equation, CO2 formed. That will be equal to, look here, 2 into 10, which means 20 centimeter cube. And from this equation, we do not have any product. And so the resultant mixture is going to be having, I'm writing, will have 240 centimeter cube of unused oxygen, 1200 centimeter cube of nitrogen, and 20 centimeter cube of carbon dioxide. And that is our answer. Did you find this video helpful? If yes, then let me know and like and comment and share it. And of course, did you get the star? Thank you for watching. For more information on the concepts of maths, physics and chemistry, subscribe to my channel and click on the notification bell so you will be updated whenever I upload a new video, and enjoy learning the easy way.